Hello everybody and welcome back to Calc 3 online. Before you watch this video, as I said online in the classroom, I wanted to make sure that you've watched the 3 blue, 1 brown video on both determinants and cross products. He does a really good job of showing the visualization of what's going on, which is something that I can't really do as well in here. So I'll let him explain that part. After you've seen those 2 videos, I just kind of want to walk you through some more, like a few examples and just kind of summarize some of the key points that he talked about in those videos. So this thing, the cross product, is a really important vector tool. And this is the definition, basically, that this is the definition, but what it does is it gives you a new vector that's going to be orthogonal to A and B. And so what that means is that, let's say C here is a vector, okay? Then we want that A dot C to be 0, and we want B dot C to be 0. Something kind of weird is that this cross product is really just defined, well, in 3 dimensions. I will kind of add this, and even more weird than that, it's also actually well defined in 7 dimensions, so R7, but I'm not going to get into that right now. I'll let your college professor someday tell you more about that. But it's kind of a weird thing, and I've proven it to classes in the past, but I think for time reasons and things right here, I'm going to let you read the proof in the book if you want of how this works. But basically, we take these 2 assumptions. This is like what we want to create. And you go through a bunch of symbolic work. But if you define A and B this way and like C similarly, you could get A cross B to equal this. And this is hard to memorize, okay? And that's why I wanted you to watch the video on determinants, because if you know this as just coming out of a determinant, then it's a lot easier to memorize. Like, I honestly don't remember this definition. I just use a determinant definition to get this. In a picture, what this is saying up here is that we're going to create this vector right here that would be normal to what I'm crossing. So, and there is another normal vector here that I could do. I could go and have a normal vector that points down, and the one that you'll get, whether it's like going up in a sense or down here, is totally determined on what comes first. So if you have U cross V, you actually would get this, and I'm going to talk about this right-hand rule some more, that tells you the direction of that. But for right now, just know what we're doing is we're creating really a new vector that's going to be perpendicular to 2 others. So what I have here is examples of a determinant in R2, in R3, and in R4. And if you ever take, so this year we're also teaching linear algebra, and if you ever take a linear algebra class, we talk about determinants a ton. Really, in our class, everything is going to be done in like R3. But even in linear algebra class, when we start studying linear transformations and all these things much more, we do a lot even in R2 to kind of get a sense of what's going on. But really, for what I need right now for you to know, everything kind of revolves around this determinant. There is a pattern here. So you'll notice in R2, all you have to do is take the diagonal here, multiply these, and then subtract these. That's it, okay? And you probably can't see the pattern really yet. You have to kind of go to the next dimension up, or maybe even the one after. So in R3, you'll notice, so this symbol too, let me just kind of do this. So when I do those bars like that, that is like the same as just saying a determinant. So if I want to say the determinant of like matrix A, it's the same as just doing matrix A and then like putting bars. Those are equal. So I wanted to show you both this way and this way. Math people are lazy, so eventually we do this one like all the time, basically. But this is the one you'll be using, and what you'll notice is it's built. The determinant of a 3 by 3 is built on the determinant of 2 by 2s. So you do need to know how to do it in 2 by 2. So the pattern is there's a few things to recognize, I guess, that we are going to do. We're going to start with this first thing. And then we're going to kind of, in a sense, I always think about it as like we're going to block that off. And then what's left over here is going to make my first 2 by 2 determinant, my dimension down. And then as I move, so that's kind of the green case. And then if I take B, I need to block out all the rows and columns with a B in it. And then if you notice, let's do like red. If you notice, you got DG, FI, and that is right here. And so whatever we block out, whatever's left over, will go in here. Maybe I'll erase this just to kind of give myself a little more room for the last one. If I do, we just keep it in red. So if I block off C, right, this part is what you'll see over here. So that's one part of the pattern. There's another part of the pattern here too, and it's that your first term is always going to be positive. So this is what I mean by like a term, right? And then you have a negative term here, and then you have a positive term here. And that pattern would actually continue if we need it more. It actually was working over here too. We had a positive term, and then we had a negative term. This same pattern, positive term, negative term, positive term, negative term, okay? And the same like blocking out tricks work here too, down R4. So if you block out A, you're gonna need to do a determinant of a 3 by 3 determinant right here, right? And then to do the 3 by 3 determinant, right, you'd have to do this. You have to go back here, and then you'd solve all that out, and then you go back here. So you can kind of start to see how if they get really big, like a 4 by 4 determinant has a whole bunch of computations. They take a while to do. Luckily, there's programs that kind of do this quicker for you. Your calculator can even do it. If you just go and type in, like if you have a TI Inspire, you can just type in DET and then take it out of a matrix and it'll tell you the determinant. It does have to be a square matrix. That's important. You can't do it for like a 2 by 3 or something like that. It needs to be 2 by 2, 3 by 3, 4 by 4. So really, again, this is the one we will use, okay? So I would not memorize all this. I would memorize the pattern in how we computed it, and it's going to save you a lot of time. So I just wanted to kind of go through one here. So again, this is like my, they talk about this in the video. There's this weird thing where what we're actually going to do is we're not going to stick vector components in every single thing, because actually up here, we're going to put ijk. You also can put ijk over down here. I think that's how it is in the video. But a lot of times you'll see it just ijk along the top. And then this is that pattern. So we're going to block the first column and row out. And that is going to be the determinant. The resulting terms are going to get scaled by that component that I block out. Then I minus, you block this out, j times the resulting 2 by 2. Block this out, do k times the resulting 2 by 2. Which again, I guess is that, but I just know how to do all the determinants, and then I don't have to memorize this. And since if we do, not that we will in this class, but in a lot of other math classes, you have to do higher dimensional determinants, you don't want to just memorize a bunch of symbols. You want to know the pattern, because that way you'll know how to do any of them. The only other thing I'm going to say before I solve this problem is putting I, J, and K in is weird. And I posted a video that said if you want to learn more about why we put I, J, and K in, you can watch that fourth optional video. But it's a lot to get into right now, and it's kind of beyond the scope of our class. So I'm going to do the annoying teacher thing and say, believe me. But there is a whole bunch of reasons why this is here, but it would take a while for me to explain it. And the 3 blue and brown guy, Grant, does a great job of explaining it anyways. Okay, so let's solve one of these. So I want to actually do 2 things. So I want to do A cross B and B cross A. So if I was going to do A cross B, I'm going to put IJK in, okay? And then A is 1, 3, 4. B is 2, 7, negative 5. And I'm just going to compute my determinant. So I would, again, I'm going to block, in a sense, these rows and columns out. And I'm going to scale this resulting determinant by I. So we got I hat times 3, 4, 7, negative 5. Then we got a minus J times the 1, 4, 2, negative 5 determinant. Then we add to it K. Should probably put little hats on these. K times 1, 3, 2, 7. And so to do the 2 by 2 ones, you just need to multiply the diagonals and subtract. So this multiplication minus this one. So we get, we're going to get negative 43 times I hat. I'm just using a calculator because I'm not good at mental math. Plus 13 times J hat. And then looks like this one's just 7 minus 6, so that's just times 1 times K hat. So this is my vector that will be perpendicular to both A and B, okay? And if I do B cross A, that's going to be, still start with IJK, IJK, and then B cross A is going to look like 2, 7, negative 5, 1, 3, 4. So I just put B in before A. And you're still going to do all the same kind of plus minus stuff. You're going to get 7, negative 5, 3, 4. And then you're going to get minus J hat times 2, negative 5, 1, 4. And then you're going to get plus K hat times 2, 7, 1, 3. And I'll let you double check all of it, but if you do this multiplication now minus this one, because of the double negative and stuff, you're going to actually get the positive 43. So you're going to get 43 I hat. Then you're actually going to get negative 13 J hat here. And you're going to get minus K hat. That one's quick to see because you just do 6 minus 7, right? And this was mentioned in the video, but it's really important, so I want to take time to do it. So if you look at this and this, you should notice that A cross B is equal to the negative of B cross A. And negative in vector world is just referring to direction. So this new vector we create just points in the opposite direction of this one. That kind of goes back to this picture where there could be this vector n or one coming down here, like negative, right? And so this is something called anti-commutative in math, where the reverse direction is negative. This actually shows up quite a bit, especially in vectors. So that's really important to know, that you can kind of get two of them, and one is just going to point the other direction. So the last thing I want to talk about is that direction. So the direction of the cross product is always following this right-hand rule. And this picture sums it up really well. If you use your right hand and you put your pointer finger on like A and your middle finger on B, then the cross product, the new one that you're going to get, is always pointing in the direction your thumb's going. So if I draw a I just draw like a I hat, and then we'll do like a J hat, and we'll do a K hat. It might help to kind of think through these examples right here, using this right hand rule. So if I was in person with you, I would show you this in person, but it's kind of hard to show it to you up here virtually. So you'll have to kind of play around with it. And I really do encourage you to with this axis in mind, think about putting your first finger here, second finger here, and really kind of see that you would get K hat for that one. Okay. If you do J cross K, you would get I hat. And if you do K cross J, so now you're going to get negative I hat. Basically, it's like in that one, first finger here, middle finger here. You can kind of see how your thumb should point back, like away from this yellow vector, right? So negative I hat. And you can always check any of them if you do the actual computation out. IJK. Let's do let's do the last one. So 0, 0, 1, 0, 1, 0. So this is going to be K cross J. If you just compute it out, right, you're going to get I hat times, come on, stylus, I hat times 0, 1, 1, 0 minus J hat times 0, 1, 0, 0, and then plus K times 0, 0, 0, 1. And if you do that all out, this first term is going to give you negative I hat, but then this thing gets killed because there's like a 0, like minus 0 in the 2 by 2 determinant. And here, this also gets killed because there's a 0 minus 0 in the 2 by 2 determinant. So you could always do them out by hand, but these are ones that I think are kind of good to teach you that right hand rule.